Preparing for a REST API interview? You've reached Interview Guide, and this video is for you. We'll walk through 21 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What makes an API RESTful? A RESTful API exposes resources through a uniform HTTP interface. I model domain objects as resources, use nouns in URLs, and apply HTTP methods correctly. Get reads, post creates, put or patch updates, delete removes. Each request should be stateless, meaning the server does not rely on previous request context. Responses usually contain representations like JSON. A good REST API also uses status codes, caching headers, and predictable resource relationships. While answering, focus on REST constraints: client-server separation, statelessness, cacheability, uniform interface, layered architecture, and resource-based URLs. Also mention HTTP methods and representations like JSON. Question 2. What is the difference between put and patch? Put is generally used to replace a resource, while patch is used to modify part of it. If I send put users 10, the payload should represent the complete user state I want stored. If I send patch users 10 with email new@example.com, only that field changes. Put is idempotent by definition. Repeated identical calls produce the same result. Patch may be idempotent, but it depends on the patch operation semantics. Make sure to cover full versus partial updates, idempotency, request payload expectations, client intent, and examples. Clarify that patch can be idempotent depending on implementation, but is not guaranteed. Question 3. How do you choose the right HTTP status code for a REST API response? I start with the outcome. For success, I use 200 for normal responses, 201 for created resources, 202 for accepted async work, and 204 when there is no body. For client problems, 400 means bad input, 401 unauthenticated, 403 forbidden, 404 missing resource, and 409 conflict. Server failures should be 5xx, not hidden as 200. Consistent status codes make retries, monitoring, SDKs, and client error handling much cleaner. In your answer, talk about status code categories, common success and error codes, client versus server errors, and why consistent status codes improve debugging and API consumer experience. Question 4. What does statelessness mean in REST, and why is it important? Statelessness means every request carries enough information for the server to process it independently. The server should not depend on a previous request or an in-memory session to understand the current call. For example, authentication details come through a token, not server-side conversation state. This makes horizontal scaling easier because any instance can handle any request. It also improves failure recovery, load balancing, and caching, though clients may need to send slightly more data. Be sure to mention that each request contains all required context. Servers do not store conversational state, and this improves scalability, load balancing, resilience, and cacheability. Question 5. How would you design pagination for a large collection endpoint? For small datasets, offset pagination like $limit 50 and offset 100 is simple and easy to debug. For large or frequently changing datasets, I prefer cursor pagination, $limit 50, cursor equals ABC. The cursor encodes the last seen sort key such as created at plus ID, giving stable traversal even when new rows arrive. I return next cursor or links in the response and enforce a maximum page size. Cursor pagination is less flexible, but much more scalable. While answering, compare offset-based and cursor-based pagination. Discuss sorting stability, next links, page size limits, performance on large datasets, and how clients should traverse results safely. Question 6. How should errors be structured in a REST API? I like error responses to be predictable. A typical structure includes an application error code, a clear message, optional field errors, and a correlation or request ID for debugging. For validation, I return 400 with details like field, reason, and rejected value if safe. I avoid exposing stack traces, SQL errors, or secrets. The HTTP status tells the broad category, while the error body gives clients enough detail to recover or display useful feedback. Make sure to cover consistent error schema, machine-readable codes, human-readable messages, field-level validation errors, correlation IDs, and avoiding leakage of sensitive internal implementation details. Question 7. What is idempotency, and why does it matter in REST APIs? Idempotency means repeating the same request has the same effect as making it once. Get, put, and delete are expected to be idempotent, while post usually is not. It matters because clients retry after timeouts, load balancers may retry, and networks fail in unclear ways. For operations like payments or order creation, I use an idempotency key so the server can detect duplicates and return the original result instead of creating multiple side effects. In your answer, define idempotency, identify naturally idempotent methods, explain retry safety, network failure scenarios, idempotency keys for post, and impact on payments or order creation. Question 8. How do authentication and authorization differ in REST APIs? Authentication answers, who are you? Authorization answers, what are you allowed to do? In a REST API, authentication often uses bearer tokens, OAuth 2 access tokens, or session cookies. After verifying identity, the API checks permissions through roles, scopes, ownership, or policies. If the user is not authenticated, I return 401. If they are authenticated but lack permission, I return 403. Authorization must be enforced server-side on every protected resource. Be sure to distinguish identity verification from permission checks. Mention tokens, OAuth 2, JWT, scopes, roles, 401 versus 403, and where authorization should be enforced. Question 9. What are the pros and cons of using JWTs for REST API authentication? JWTs are useful because the server can verify the token signature without a database lookup, which fits stateless APIs and distributed systems. They can carry claims like user ID, issuer, expiry, and scopes. The downsides are token size and revocation complexity. Once issued, a JWT remains valid until expiry, unless you add block lists or short lifetimes. I keep JWTs short-lived, sign them strongly, avoid sensitive claims, and pair them with refresh token rotation. While answering, discuss stateless verification, claims, signing, expiration, token size, revocation challenges, secure storage, refresh tokens, and why JWTs should not contain sensitive data. Question 10. How would you implement versioning in a REST API? I version APIs when behavior or contracts change in a breaking way. The most common approach is URI versioning, like act/v1/orders, because it is visible and easy for clients to reason about. Header-based versioning is cleaner architecturally, but harder to test manually. I try to avoid breaking changes by adding optional fields and preserving old behavior. When deprecating, I publish timelines, migration guides, warnings, and usage metrics before removing anything. Make sure to cover URI versioning, header versioning, backward compatibility, deprecation strategy, semantic changes, documentation, and minimizing breaking changes for existing API consumers. Question 11. How do you design REST API endpoints for nested resources? Nested resources are helpful when the relationship is part of the resource identity or access pattern. For example, get users 42 orders clearly means orders belonging to user 42. But I avoid deep chains like /company/1, user/2, order/3/item/4, because they become brittle. For many cases, filters work better, /orders user ID 42. I also enforce ownership on the server. The URL structure improves clarity, but it cannot replace authorization checks. In your answer, explain resource relationships when nesting improves clarity, avoiding deeply nested URLs, ownership checks, filtering alternatives, and examples like users, orders, and items. Question 12. What is the difference between 401 unauthorized and 403 forbidden? 401 means the request is not properly authenticated. The token may be missing, expired, malformed, or invalid, so the client may need to log in again. 403 means the server knows who the user is, but the user is not allowed to perform that action. For example, accessing/admin without a token is 401. Accessing it as a normal logged-in user is 403. This distinction helps clients respond correctly. Be sure to clarify the confusing naming: authentication versus authorization, missing or invalid credentials, valid credentials without permission, and practical examples for protected endpoints. Question 13. How would you handle rate limiting in a REST API? Rate limiting protects the API from abuse, accidental traffic spikes, and noisy clients. I define limits per API key, user, IP, or tenant, depending on the product. Token bucket is a strong default because it allows short bursts while controlling long-term rate. When clients exceed limits, I return 429 with headers like retry after, X rate limit, and X rate limit remaining. In distributed systems, I use shared stores like Redis or gateway-level enforcement. While answering, cover fixed window, sliding window, token bucket, user or IP-based limits, response headers, 429 status code, distributed counters, and protecting critical services. Question 14. How does caching work in REST APIs? REST fits well with HTTP caching because resources have stable URLs and GET is safe. I use cache control to define freshness, etag or last modified for validation, and conditional requests like if none match to return 304 when data has not changed. Public data can be cached by CDNs, while user-specific data should be private or not cached. The hard part is invalidation, so I design cache keys and freshness rules carefully. Make sure to mention HTTP caching headers, cache control, etag, last modified, conditional requests, public versus private caches, invalidation challenges, and safe caching mainly for GET responses. Question 15. What is CORS, and why do REST API developers need to understand it? CORS is a browser security mechanism that controls whether front-end code from one origin can call an API on another origin. The server opts in by returning headers like access control allow origin, allowed methods, and allowed headers. For non-simple requests, the browser sends an options pre-flight first. If credentials are involved, configuration must be stricter. CORS does not protect the API from non-browser clients. Authentication and authorization are still required. In your answer, explain browser same origin policy, pre-flight requests, allowed origins, methods and headers, credentials, options handling, and why CORS is not an authentication mechanism. Question 16. How do you handle validation in REST API requests? I split validation into structural and business validation. Structural validation checks required fields, types, formats, length, and allowed values, often using a schema or DTO layer. Business validation checks rules like account status, inventory availability, or date constraints. On failure, I return 400 or 422 with field-specific error details. I also sanitize inputs where appropriate and never trust client-side validation. Good validation makes the API safer and easier to integrate. Be sure to cover schema validation, required fields, type checks, business rules, field-level errors, sanitization, fail-fast behavior, and returning useful 400 responses without exposing internals. Question 17. When would you return 200, 201, 202, and 204 from a REST API? I use 200 when the operation succeeds and returns a response body, such as fetching or updating a resource with the latest representation. I use 201 when a new resource is created, usually with a location header pointing to it. I use 202 when work is accepted but not finished, like starting a background export. I use 204 when the operation succeeds but there is no response body, commonly for deletes. While answering, describe the difference between normal success, resource creation, asynchronous acceptance, and no content responses. Include examples and mention location headers for created resources. Question 18. How would you secure a REST API beyond authentication? Authentication is only one layer. I require HTTPS, validate all inputs, enforce authorization at the resource level, and follow least privilege for service accounts and database access. I add rate limiting, audit logs, request IDs, and monitoring for suspicious patterns. Secrets should live in a secret manager, not code or config files. I also avoid excessive data exposure by returning only necessary fields. For sensitive operations, I consider replay protection and step-up verification. Make sure to cover HTTPS, input validation, authorization, least privilege, rate limiting, logging, secrets management, secure headers, audit trails, replay protection, and avoiding excessive data exposure. Question 19. How do REST APIs compare with GraphQL? REST exposes predefined resource endpoints, while GraphQL lets clients request exactly the fields they need from a schema. GraphQL reduces overfetching and underfetching, especially for complex front-end views. REST is simpler to cache with HTTP, easier to observe at the endpoint level, and often better for public APIs with straightforward resources. GraphQL needs careful control around query cost, authorization, and caching. I choose based on client flexibility needs, team maturity, and operational complexity. In your answer, compare resource-based endpoints with query-driven schemas, overfetching, underfetching, caching, tooling, versioning, performance control, and when each style is a better fit. Question 20. How would you design a REST endpoint for file upload and processing? For small files, multi-part form data through the API may be acceptable. But for large files, I prefer pre-signed object storage URLs. The client uploads directly to storage, then calls the API with metadata and the file reference. Processing should usually be asynchronous. Return 202 with a job ID, then expose a status endpoint. I enforce size limits, content type checks, scanning, and authorization. This keeps API servers from becoming bottlenecks for binary traffic. Be sure to discuss multi-part uploads, pre-signed URLs, size limits, async processing, virus scanning, metadata, progress tracking, 202 responses, and separating binary storage from API servers. Question 21. How do you make REST APIs observable and easy to debug in production? I make every request traceable. Each request gets a correlation ID that appears in logs, downstream calls, and responses. I collect metrics like request count, latency percentiles, status code distribution, and error rate per endpoint. Distributed tracing helps identify slow dependencies. Logs should be structured and safe, without tokens or sensitive payloads. Dashboards and alerts should map to SLOs, not random thresholds. Good observability turns production issues into searchable evidence. While answering, cover structured logs, correlation IDs, metrics, tracing, latency percentiles, error rates, audit events, request sampling, safe logging, and dashboards or alerts tied to SLOs. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.